This is part 2 of our video on vector operations. We just did the first page and now we are on the second page. So these are the same 4 vectors we were working with on the previous side. We have vector A, B, C, and then 0, which it has no direction or magnitude, so it's just a dot. All right, so we have A minus B plus C equals A minus B plus C. So I'm interested in investigating whether the location of the bracket makes any difference at all here. So I have A minus B plus C. So I'm going to start by doing A minus B. Order of operations says we do the brackets first. So I am going to draw A minus B, and then to that we'll find the resultant, and then we'll add C, and then we'll try the second part. So I am subtracting, so I need to give myself a little bit of space to go the opposite direction. So I know A is 2 squares up, 1 square over. That's A. And then B is 2 squares over, 2 squares down. But we have to go the opposite way because we are subtracting. And we always go the opposite direction when we subtract. So this is minus B. And I'm going to find the resultant for those because that's what it asks me to do first, is find A minus B. So this is A minus B. Okay. Then what it wants me to do, now that I have A minus B, it wants me to add C. This is going to get a little squishy. I didn't really leave a lot of room here. So from the end of this one, A minus B, we are going to add C. C is going 2 squares straight down. So from here, we are going 2 squares straight down, and that is vector C. All right. So that means the resultant of A minus B plus C is this little guy right here. This is my fault for not making these further apart. This one is A minus B plus C. Okay, so I guess if these are equal, what we're looking for on the other side is one that is 2 squares up and 1 square over. All right, well, let's give it a try. So this side is asking us to do B plus C first, and then we're going to end up taking that away from A. So I think I need to add B and C, see what we get, and then we will subtract that from vector A. So B plus C. So my B goes 2 over 2 down. So this is B. And then we're adding C. C goes straight down 2 squares. And then my resultant from that should start at the beginning of B and end at the end of C. And that would be B plus C. Now, I know what B plus C now looks like. It is going 1, 2, 3, 4 down and 2 over. Okay, because I need to do A minus B plus C. And I think we should start a new diagram for that. I think it'll make it easier. So I'm just going to come up here and I'm going to draw A. And then I'm going to take B plus C, which is going 4 down and 2 over, and I'm going to do the opposite because we are subtracting. So I'm going to go 4 up and then 2 over the other way. This is minus, and then B plus C. And then if I draw in my resultant, start at A, we end at the end of minus B plus C. We get A minus B plus C. Okay, is this vector the same as this vector? Well, they would need to have the same magnitude and the same direction. And I don't know if you noticed, this one is very short. It's 2 up, 1 over. This one here is 6 up, 1 over. So I'm going to say I don't think those are the same. So no, that's false. All right, we have one last property to prove. And that is this one, that 2 times A minus B is the same as 2A minus 2B. Now, if I think about this from a math perspective, right, this would be distribution if it works out, that 2 times A minus B is 2A minus 2B, right? So I would hopefully, we'll see if that works out or not. All right, so 2A minus B means I'm going to take A minus B, and then we'll figure out what that is, and then we'll draw 2 of them. That's what that means. So I'm going to do A minus B. So A, we have drawn A minus B before. Here's A. And then B is going the opposite direction that it normally goes. Okay, and then my resultant is here. Okay, and then A minus B, 2 times A minus B means I have to take this and do it twice. So this is going 1, 2, 3, 4, up, 1 over. So then I'm going to draw another one, 1, 2, 3, 4, and then 1 over. So this whole big long thing would be 2 A minus B's because I have A minus B and then I have another A minus B on top of that. Okay, that's the one we're looking for to compare with. All right, 2A minus 2B means I'm going to do 2 A's. So I'm going to maybe start here and I'm going to draw vector A and then I'm going to draw a second vector A, so that I have 2 vector A's. And then minus 2B, we're doing minus, so we're going the opposite way. I'm going to draw a B, and then I need to draw a second B, because there are 2 B's. And then I'm going to draw my resultant, and then see whether or not it's the same. Well, just looking at it, it looks parallel. This is 1, 2, 3, 4, 5, 6, 7, 8, up, 2 over. This is 1, 2, 3, 4, 5, 6, 7, 8, up, 2 over. So that's good. And they're pointing in the same direction. So I'm going to say that these 2 vectors are indeed the same thing, which means that our regular rule for distribution works with vectors. So what we're going to find is with vector operations, the operations that we do are basically just algebraic operations, right? You can distribute into a bracket, you can collect like terms. If you add A plus B, it's the same as B plus A, right? That, you know, and a vector plus 0 is just the basic vector. So they're really just basic algebra rules. All right, so in the next video, we will try some examples where we use these new skills.